Hi there, this episode is an audio rip of a YouTube video. If there are any references to the screen or to the video itself, then be sure to go over to YouTube and actually check out the video, which will be the same title as this podcast. Thanks. Okay, hello and welcome to episode 13 of the 2396 Design Course series. Today what we're going to do is we're going to take a look at the how to approach the project, the large practical project task. The project's supposed to take about 40 hours of work, but some training companies will give you a year or 2 years or something. What often can happen is you go on the training and you do day after day after day after day of calculation exercises, and you have your assessment or your exam, and then you're told to go and do a project, and the project is assessor marked. So whilst the City Guild will do an external verification on that to make sure that it's good enough, there's no real answer sheet, and that makes sense because there's 101 different ways to do a design, and if you were to say, oh, they must design it this way, that's kind of being a bit silly. What they will do is they'll look at the paperwork that you give them. And remember, I've mentioned in previous videos the importance of an OEM, making sure you give them all the information in the design that you have. Give them that information, and then what they need to do is verify that you've worked with it properly. So with the drawings, you can draw your cable routes and all your wiring, and then they can do the calculations that you've been trained on to verify that everything's okay. What I advise though is, it can be hard to approach it because it sounds like a minefield of work. It's a lot to do, and quite often you can just be left to your own to do it. And what we need to do really is, and my advice is to spend the first couple of sessions, whether that be a day session or a couple of evening sessions, to actually not plan to actually create any design yet, not put anything down. What you need to do is just sit and consume the information. So you'll have provided for you, you'll have something like this mock example. So you're given a scenario of the of the site, the client, the utilization, so how it's used, what the purpose of the store is, the construction, what the fabrics of the building are, the walls, the floor levels. So you can, these are all there for you to determine methods of install. What wiring systems you need to select and what wiring systems you can get away with. A very important one for us in particular is the ceilings. Quite a large area of this plan that we've got here, for example, has a suspended ceiling, so we can be quite free above the suspended ceiling as long as we secure the fixings properly, and we get quite a bit of freedom for that. And then you have the supply information, which we're going to use later on in another video, where we have that supply characteristic. We have the ZE and the PFC, and we need to verify an awful lot of things to verify protection of electric shock is there. So that information is essential, but that's all here. And then the last bit just tells us that we must comply with 7671 and hoists, lifts, telephones and stuff's outside of the scope of our design. At the bottom of this there would be an attached drawing, but you can also download directly from City Guild, or you may have been provided with digital copies of the drawings for the current project that's in place, and they're fairly good editable drawings. Now, when I did my 239120 project, the first thing I did, the thing I suggest that you do, is I had the clean copies provided by the trainer. But what I did is I took copies of those, just photocopies, and then I just drew on those. So I kept the stuff clean until I had my final design idea. And what I actually did is I had an A4 piece of paper with the diagram on, and I got those clear, those overhead projectors with the clear overlays that you could put over, and I had a pen and I'd put an overlay over the diagram, and I would draw a route for the trunking, and then I put another overlay on. Then in that trunking I would draw the circuitry of the earthing and bonding, or the main protective bonding, or the circuitry of the light circuit. So I had an overlay for every kind of thing. It was easy to manage, it was easy for me to kind of not go on top of things. But nowadays, obviously, you may have access to something like Photoshop, and so you can just add the layers in there, if that's easier for you, whatever's easiest for you to work with and to manage it. That's absolutely fine. Starting point, though, is read the information, get a good understanding on the actual project, on what you're being asked to design, where you're being asked to design it, and the types of wiring systems you're going to naturally adopt. The next thing you need to do is, once you've studied your drawings, and going back to that, we can just look at this here. So we can see with this one we've got our intake position here, and next to that we've got DB1, but also we have upstairs a DB2. Now there's nothing in the actual spec that says that DB1 must be just power and lighting, or DB2 must feed X, so in this case I'm just going to go with, this is for upstairs power, DB2 upstairs, and this is for downstairs power, DB1 downstairs. It just keeps things simple really for me. And again, fundamentally that doesn't matter as long as the specifications haven't asked for it to be different. The person marking just needs to verify that the method you've chosen to use, you've calculated the data correctly to work with that method, and that the method isn't a little bit stupid. So I'm noticing a couple of things with this drawing in particular. So I have my intake switch from here, but I have right next to it a goods lift, and I know from the wine regulations that we are not allowed in a service lift or a lift area. So I can't run power this way. So my main power is going to start off going this way. I also have a hoist which we can't get into that area for, and we have the staircase. So I'm going to bring my main power in this direction, and then I'm going to go this way, and we're going to have our suspended ceiling. So what I'm thinking is I'm going to run a main distribution all the way along the middle, and I'm going to come off of it with lighting and power in different directions for different circuits. I also notice a couple of larger power demands. So I see there's a 32 amp 3-phase supply here for a hoist. I can see over here 2 single-phase 32 amp supplies for the air curtain. Other than that, that's it. Everything else is lighting and power. So what I thought I would do is run a trunking, metal trunking, along the main centre of the catalogue shop, and I'd then come off in conduits towards the small power. But for the trunking, these 32 amps, it's probably going to be a pain in the ass. So what I probably will do is I'll either run a ladder with both a trunking and a tray on it, or I might just run a trunking and a tray beside each other. We'll see as this goes later on. But what I can do right now is say, right, I can't go this way, I have to come this way, and then I want to go through the middle so that everything is of fairly even length of travel. Okay, and bear in mind this is the suspended ceiling. I can go over the suspended ceiling absolutely fine. This is the suspended ceiling. This, although it says in the scenario the suspended ceiling is not in storerooms, intake and stairwells, I'm going to assume then that this, because it's a goods in, there's racking, I'm assuming this is a storeroom. So I'll have the trunking in here, it'll be mounted nicely in conduits, but then over here it's just above the suspended ceiling, so it should just go in a straight line. Should get away with that. What I'll then do is decide what arrangement layout for my lighting and which route my conduits will go, and then I've got my small power, and we'll go from there. So if I go to Photoshop, bear in mind I've only spent 2 hours on this. I just needed it. I've had so much stuff with the 18th edition coming up and Royal Ascot and stuff, but I need to get some movement on this because I know people have been asking for it. But I'm going to do a follow-up video on this where I will show you the calculations for these routes that I'm showing you now. Even if I notice later on that these routes are a bit shit, I'm going to go with these and I'll do calculations for these. And it may be we determine the routes could be better because of the calculations. We'll see. So as I've suggested, I'm going to take my main distribution run from the board, and I'm going to go, I can't go this way, I'm going to go this way, around, and I'm going to go all the way through the middle. I always go through the middle if I can get away with it, that way everything is of shorter run. The trays, which will go along it, they may also extend. So here's something that marks the additional length for tray. So I've got this extra tray, this is the trunking ladder / tray run. Then I've got this bit here going here, which is just for this 32 amp 3-phase supply. I have at the end here, for these two 32 amp 3-phase single phase supplies. And then there's this last one here, which is, again, it's just for the main bonding. I may put a small tray in to carry the bonding nicely. It doesn't really matter, I just need to know the route so I can determine the length. The next thing I need to do is decide what switching arrangement I'm going to need. Because if I look at the drawing, there's no actual light switches here. The light switching for this area is actually, there is a multi-gang switch here and here for it. So what I need to do is get all my there'll be a big grid switch, and they're going to be switching all of these. Now I need to say, okay, well, do I want all of this on 2 switches, 3 switches, 4 switches? And to work that out, I think about common sense. Do you want 20 switches, 8 switches, whatever? But I also think about loading and layout. Now these are your 1200mm lamps, so off the top of my head that's the 58 or 54 watt ones. So probably looking at 5-6 amp for 10 of them. So on 10 amp circuits, I could switch 10 on a 10 amp circuit quite easily. That's my initial approach. So I'm going to think about putting 10 on a switch. And so what I need to do is just think about a layout. So if I have the first one on the first switch, okay, I've gone instead of going in a line like that, I went across, so that if one light switch fails, it's not an area of darkness, there's shared lux from the other circuit. So there's one, there's the other, and then 3 and 4. So those are the 4 circuits I have at the moment laid out. That's all of the main area. The jewellery sales does have its own switch, but I'm going to include that for the ELV lighting here, which will just be on a little plug-and-click rose, and these will daisy chain off. And the same here for these ones. Probably, there's a multi-gang, so I'll probably have 3 on 1, 3 on 1, 3-gang switch for there, and 2-gang switch for there. Fundamentally, the lengths aren't going to change according to how I switch them, so it shouldn't be an issue there. But that's my initial approach with the lighting for that. I've now got my lighting out here, 8 lamps. There's a line here. Let me just go to this other drawing so you can see it clearer. There's an illustration. It shows you that this light and this light must work together on a 2-way configuration. Similarly here, this light and this light and this light on a 2-way configuration. That doesn't mean they have to work on their own circuit 2-way. What it means is from an operational perspective, if someone was to come in here and hit a switch, the switch that turns the lights on shall turn all of this route on. This route shall be lit in a 2-way means. So if you come in, you turn a switch on that hits these on, then as you leave, there's a switch that turns them off. Similarly here. So they can be on the same circuit because they're 2-way switched. Alright. So what I did in this case is this was 8 lights, so I just sort of sod it and I just put them on one circuit. And similarly here, 1, 2, 3, 4, 5, 6, 7, 8, 9, I put them on the same one. For now, just kept it simple. I haven't looked into the intake room or the stairwell yet. I was just thinking about, I don't want 101 light circuits. I just need to make sure that they're evenly balanced and they're evenly distributed and they're evenly switched. You could argue that, you should have these on 2 separate switches. I might decide that later on, but for now I just need to think about the wiring systems. I have already had a little thought about emergency lighting. There's obviously a doorway here and a doorway there, so there's emergency lighting there. There's obviously a doorway through, and I've had an estimate at the spacing at the moment, but what I will be doing is I'll be digging up 5266 and I'll be looking at the required lux levels to make sure I have suitable spacing on all of that. And I haven't even done the emergency lighting for the back end yet, but do remember you should be considering that as well with your design, unless it says in the spec that you are not doing that area. We should be considering it with our design if we're putting this in. I'm not going to be thinking about a dedicated emergency lighting system with a standby supply thing, because this is a single catalogue shop. It's not a place of occupation, of habitation. It's not a place of people who are vulnerable. It's a small catalogue shop. Alarm goes off, out you get. So simple, non-maintained or maintained luminaires will suffice off of the normal electrical installation. I don't think there's any need for any further scope for that. The conduit runs. I started off by thinking about running the conduits like this, so a conduit to those lights, the conduit to those lights, the conduit to those lights, all from this trunking. And at first I thought, God, that'd take the mick if I was doing that actually I then realised that the length of cabling was also quite long by running backwards like this to the trunking every time. I just thought, no, it's not practicable. So I then thought, okay, well, I'll go out, I'll go through that with a plug-in click rose with a through box to a T and then to another one. So my theory is, you know, the plug-in click rose is above the luminaires. And what I'll then do is I'll go along, and then either, depending on the scale, I'll just put through boxes, 2 throughs here with a plug-in click, or ideally they should be above the luminaire. So what I might do is then just go with tube work off there to a stop end, like that. Okay, so haven't quite decided. I think that's probably how I would do it, similar with down here. You'll notice that these two here, this one has been moved to the side because of the pillar. Same up here. Always, you know, just make sure you don't cross the pillars when you're doing overlays. Make sure you've not compromised any of the building, because otherwise, you know, your assessor will pull that up. But so right now the power will be running from the board through the trunking, and then I've got conduit this way for switch positions. Sorry, here, this one for a switch position, and then and then I'll go through to the lights. So for this circuit, it'll be boom, 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 boom. Yeah. Neutrals and switch lines, and obviously there's a permanent live, it'll run through there. I've had a little look at the cable capacities right now, assuming that these are 1.5mm cables and doing the counts, and I know that I can get more than 2 circuits in this single 20mm tube, absolutely fine. But I haven't verified finally the sizing of the conduit yet, because you shouldn't size conduits or trunkings until you've sized your live conductors, because the actual the way they work is in the on-site guide, and I'll do these in the next video. I'll show you how I've worked them out. But you have the factors, so you count the number of live conductors, or the number of cables, being 1, 5, 2, 5. They all have a factor number. You count them up. You have a multiplier of how many there are, and then there are factors for the conduits, and you must obviously select the next one up so that you can know that they can carry that. I've had a little look at that, and this route I'm having isn't instantly becoming a problem. It's okay with 20mm, but I will confirm that in the next video. For now, I'm just trying to look at routing of wiring system. Where are we now? Okay, so that's that. I've also got in here then, there's conduits going in here, so I've got a light switch in this position, so from the main power there'll be a drop for a light switch position. That'll then go back up into the trunking, and it'll just go in a straight line with stop ends at each end, really. Little plug-in clicks, nice and neat, you know, symmetrical. I just went like that, nice simple route. Alright, so that was the lighting kind of done at that point. Bear in mind I haven't looked at this bulkhead above the stairs yet, or the intake room, but those are negligible little considerations really. This is the stuff that can delay you getting progress and moving forward. So I've got that done. The next thing was the small power, because obviously it's going to be in the same wiring system. So I've got to look at the small power sockets that are in. I noticed some along this outside wall. I noticed some in the jewelers. I noticed some on customer services and some down here. And there's these 2 above the ceiling for the TV monitors. So I thought I'd put radial circuits in, and I'll put 1 circuit for this firewall, which also fed these monitors. I'll do 1 for this firewall. Then I'll do another one for the till points and another one for the jewelers. So we've got the first one here. Comes off the trunking. This is the tube work to the back. Goes along the back to picking up these sockets, and then it comes. Bear in mind the counter's lower down. I mean, otherwise I could have gone down here and gone this way, but I've gone along the back wall and then down and then under the counter. It could be that I could assume that I can go down here and go this way. Fundamentally, I think because I have to get power there and power there, the length isn't really going to be a difference no matter which way I go. So that was the first one. Next one. This one is just the teals. You'll notice the tube work goes from socket to socket this way, and then this way, and then it's going to go up the wall, and it's going to rejoin a tube that's not there yet, because that's part of that circuit. So here's the tube work for the other radial for this outside wall, and it picks up this one near the pillar. What I'll do is I'll have 2 radials running in this tube work, and then here I'll have a T-box. One radial will carry on, and the other one will go down and feed the counters. I've already looked at my sizing of conduit, but I will confirm this after I verified what size these lives should be. It might be I have to go to 32mm, we'll see. Next radial is this firewall this side, so from the trunk in all the way along to the firewall, picking up the 2 above the ceiling. There's one just off the trunk in there, there's one there, and then here's the first socket. And again, it could be that I go along and I go down, and then I go along horizontally low level, or it could be I go down and I come back up, and I go down and I come back. You know, it doesn't matter which way I do it, but I do need to make sure that in my design I say go down, come up, or go down, stay down, because that's going to affect. Here's obviously the height. This dropping down is going to affect length, and I need to verify that when I do my calculations. So it might be that staying in conduit flush, going down and staying down is better for volt drop. Okay, but then I'll come back up here to go above the ceiling to pick up on that beam there. Yeah, or depending on the floor, I could go along the floor. It really depends on what I do. Whatever decisions I make, I must describe in the project, and I must actually then measure it to match my description so that the assessor can see that I've roughly got it right. What I will be doing though is when I actually come to do the calculations, the next step for me would be to label these circuits. I've already kind of started that. You can see here with light circuits 3, 4, 5, circuit 6, radials 1, 2, 3. But I'll call them what they are. But then what I'll do is I'll say the measured length is. It might be that I measure length to be completely wrong with the way my wiring system suggests. But if I say my measured length is 32 meters, and I then carry out calculations to 32 meters, at least the assessor can say, right, well, he's made that one problem with his measurement, but everything else he's done okay to his assumption. So you want to state what length you've got and what length you're working to, so that he can then verify to that later on. Okay, so we're at that point. Yeah, we'll call it there. We'll call it this one for now. So the important thing is to spend your initial session of study time on this, studying the project, studying the instructions, studying the diagrams, get an understanding in your mind of the building fabric, the building layout. I mean, this was a catalogue shop. I could easily pop into a catalogue shop to get an understanding on how they're actually erected. And your project may be a fire station or a training centre or an office, or whatever. They're not going to be completely fictitious things. You can just pop in and have a good understanding on how they're used anyway. But the fundamental thing really is to get this good understanding of what the requirements are for the layout and for the structure and for the appropriate wiring systems. I know, according to the instructions that I had, that my sockets are all to be flush. And I know that it was here somewhere. Here we go. I know that all wiring systems and accessories have to be flush mounted with a matte chrome finish in public areas or metal clad finish in all other areas. So if I was to say in my design, I'll have surface mounted tube work down that wall, that shows I've not followed the client's request. So it's absolutely fine to do this kind of thing, but as long as you're saying to yourself it will be flush mounted, sink it in the wall, make sure your design reflects a flush mounted install. If I said, I'm going to put dado trunking plastic surface mounted along the wall here, along all these sockets, that tells the assessor that I've not read the spec properly. This should be a flush mounted tube work wiring system with, in the public area, nice polished pretty sockets. Alright, so do make sure that you follow through to the spec as much as you can. There we go. We'll leave it at that. That's the point of this video. It's just to try to give you that push. Study the spec, study the diagram, soak it all in, and then think about the suitable wiring system route. Make sure the building doesn't compromise any of those decisions. Keep it simple, keep it clean. you know, choose whatever method you want to actually start jotting it down. Once you're at this point, I mean, I'm not going to do upstairs, I'm just going to do the downstairs for these videos, but once you're at this point, you can then say, right, well, I can now measure these lengths, and I can determine the lengths, and I can now select line conductors, select protective conductors, because I know the ZE and I know the fault current, I know the breaking capacity, I can select my device types, I can then verify volt drop, I can then verify, and you can do all that stuff now. And then if you verify the live conductor sizes, you can then verify your containment sizes. You can verify that this trunking should be 50 by 50 or whatever, this tube work should be 25, 20 mil, whatever. You can do all that at that point, but you need to know where they're going so you can get the lengths. With regards to measuring, I shrunk the drawing down a couple of times and then blew it up, and you'll have a proper A1 drawing, you should have, which will be your 50:1 scale drawing. You could use that, but again, I'd suggest you keep that clean as long as you can. What I've done is, this luminaire here, in this drawing, it's an 1800mm luminaire, so I kind of go, well, if that's 1800mm, I can then put my ruler up to the monitor and I can actually project that, okay, well, X is 1800 millimeters, so I can then upscale that, and that's what I've done. And I've actually got right now a little scale here that actually tells me for every millimeter that I measure on this drawing, I can then go by times 100, then over 1000 to make it meters, so I can just take a 0 off. So if I measure something here to be something like 300 mil, I can just take off a 0 and it'll be 30 meters. So I have that little ease adjustment for scale, but do make sure you don't get confused with your scale. Do make sure you understand that. Yeah, I'm going to leave this video here. What I'll do is I'm going to try to get some time on the next video. What the next video will be me actually having measured a couple of these circuits, and I'll look at bunching, grouping, and then I'll be doing IB, IN, IZ, doing a couple of cable calcs to go with it, and then we'll obviously consider what protected device types we need. Then we'll just talk about regulations a little bit, what protective measure we're going to be using. Are we using ADS or double insulation protection or electrical separation? We'll talk a little bit regulation about it, just so that we're keeping our minds with that. And we may also look at another video where we'll look at how to start creating the test documents, because a designer, and I've said this in previous videos, a designer can calculate ZS by calculation, because that's what the purpose of the design is. So we can say, ZE R1, R2, so ZS should be this. We can start to actually see how we obtain those numbers, and we can create those to go with this. It all looks very nice and finished at the end of the day when you finished it by doing it that way. It's fairly simple stuff. The problem is just getting motivated. But if you don't start like this, if you don't start by understanding how the wiring systems are going to run, how you plan to employ them, and you must understand them, you must understand how they're going to run, so you understand how you're going to wire through them. There's no point taking a tube from A to B if you actually have to take your cable to C. Alright, so do make sure you're understanding that, and you have the freedom through your tube work or your trunking work to do that. But if you don't start like this, if you don't start by getting your wiring systems laid out, and you're thinking about starting off with cable calculations, your lengths, your routing, won't add up. If you just, for example, went with your drawing, where is it there? If you just said, oh well, I'm going to go from the board to this thing over, where's the there, board to that, oh well, that's blah blah blah. If you just measure along this wall and then you go like that and you think that's your length, but it turns out that you ended up putting a trunking through here, then everything's going to be wrong. So you must know your route of your wiring system first, understand that, and then everything's good. If you don't do that, you're pissing in the wind with everything else. Alright, okay, we're going to leave it there. We'll leave this video at this point. I will I'll try and get another video up by the end of the week, moving on with this, but I need to get some 80th edition stuff done. Yeah. Okay, hopefully that's helped some of you go forward and start off, but do comment and let me know if you're having any issues with your thing. I'm aware of what the current project is. I can't talk about it, because unless you've been given it by your college, So you've been issued it. I can talk about it with you then, but I can't talk about it unless you've been issued it. Alright, yeah. Speak to you soon. Bye bye.